Figures 8.7 through 8.9, date.java, employee.java, and employeetest.java. In this example, we're going to introduce the concepts of composition. Composition is a form of software reuse in which, as you build a new class, you embed in that new class as instance variables references to objects of other existing classes. So in this example, we're going to be creating our own date class, and then we're going to use references to objects of this date class to help us build an employee class, which will consist of a first name string, a last name string, and two dates, one representing the birth date of the employee and one representing the hire date of the employee. So we'll talk about the composition concept again in a few moments, but first let's take a look at our date class. Our dates are going to be represented as three integers for the month, the day, and the year, respectively. We've provided a constructor that receives the integers representing the month, day, and year, and it's going to initialize our instance variables. The month instance variable will be initialized with the return value of our checkMonth method, and this, because it's a method name by itself, is really a call to this.checkMonth that's going to receive the current month value that we got as a constructor argument and check to make sure it's valid. You can see that method down here at lines 23 through 33, and notice in particular that this is a private method. That means we're only going to allow use of this method inside the body of this class. You might refer to such a method as a utility method. It supports the execution of some of the other methods in our class. Now, checkMonth is going to take the value you give it and make sure that it's greater than 0 and that it's less than or equal to 12, and if so, it will return that value. Otherwise, it's going to display a message indicating that it was an invalid value, and it will return 1 as the default month value. So if you give me an invalid month, I'll set the month to January. And again, this is a case where the concept of exception handling might come in handy to indicate to the client code that an invalid value was provided. After we do the initialization of the month, we set the year to whatever value was passed to this constructor. We probably should validate the year as well, but we're going to assume for simplicity here that you give us a valid 4-digit year. And then finally, at line 16, we are going to check the day value to make sure that based on the month and the year value, it's a valid day for that month. So we're going to call checkDay, which is down below here. And checkDay starts out with an integer array called days per month. It's actually a 13-element array, and the reason we made it 13 elements is so that we could use our month numbers of 1 through 12 as indices into the array to pick off the correct number of days in the given month. So if I want to know how many days there are in January, January is month 1, and that will pick off the number 31. February is month 2, and that will pick off the number 28, etc. Now, for most months, lines 42 and 43 can tell you if the day is valid. We'll take the test day value that was passed in and make sure it's greater than 0 and that it's less than or equal to the number of days in the current month. If that's true, we'll simply return the test day value. If it's not true, we will do a leap year test, and this is only if the month is 2 and the test day is 29. So if it's February and we want to know if it's a leap year because we're trying to set the day to 29, then what we're going to have to do is this leap year test, which is specified as the rest of the condition of this if statement. And it's an OR test where either this condition must be true or this other condition must be true. Now, the first condition asks whether or not the year is divisible by 400. If after this operation is performed, the remainder is 0, then the year is divisible by 400, and all years that are divisible by 400 are considered to be leap years. The other test says to check whether the year is divisible by 4, but it's not divisible by 100. So if it's divisible by 400, it's a leap year, and if it's divisible by 4, it's normally a leap year unless it's divisible by 100. If it's divisible by 100, it's not considered to be a leap year. If we get past this part of the body of checkDay, then we would know that we had an invalid day, in which case we'll print a message saying that we're setting the day to 1 and we'll return the value 1. Back up in the constructor, the last thing we do is output the string saying that the date object constructor for date and some value was called. We just want to show you when this constructor gets called. And notice what we're outputting as a string here. We're outputting this. And guess what that does? It says output this object as a string. And you know what happens when you output any object as a string. The object's toString method gets called. So let's take a look down at the toString method here. At line 55, toString is being overridden once again to say how to return a string format for our date class. We're using the string class's static format method to produce that string, and we're going to output our 3 integers representing the month, day, and year separated by forward slashes as our string representation. Now let's take a look at our employee class, which is going to embed references to 4 objects as instance variables in the class. What we can say here is that an employee is composed of a string representing the first name, a string representing the last name, a date representing the birth date, and a date representing the hire date. You can also say an employee has a first name, has a last name, has a birth date, and has a hire date. In each case, the has a is a representation of the so-called composition relationship. And we're going to study a different relationship in the second part of this video course called the is a relationship, which has to do with inheritance. So now that we know an employee has each of these things as part of it, we need to be able to initialize those things. So we've provided a constructor for class employee, which receives 2 strings and 2 dates and uses them to initialize the instance variables of the class. Now this gives me an opportunity to talk a little bit more about a special feature of strings in Java as well. You'll notice here that we have first name is assigned first. First name and first are both references to string objects, and now they both refer to the same exact string object. And remember, all objects in Java are dynamically allocated. So this should scare all of you C and C++ programmers, because if you recall from those languages, if you have a pointer, or multiple pointers pointing to the same dynamic memory, that can be very dangerous, because if any one of those pointers is used to remove the dynamic memory, the other pointer is left dangling with nothing to point to, and that usually results in programs bombing or something going wrong with program execution. Well, that's not the case in Java. If you have more than one reference to a given object in Java, Java will not allow that object to be removed from memory. The garbage collector, which we'll discuss more in a subsequent part of this lesson, is not allowed to retrieve an object until its so-called reference count becomes 0, meaning there are no more references to a given object. So you don't have to worry about one reference being used to remove an object and having a dangling reference because of that. But what about the possibility that one of these references could be used to change the first name? Well, we don't have to worry about that either in Java, because in Java, string objects are what we call immutable. They cannot be changed. And they do that for optimization purposes. There is another class called string builder that you can use to actually build up a string that is modifiable. But for the concept of just plain strings, once they are created, they are a constant, and then anything that looks like it modifies a string is actually returning to you a copy of that string with the modifications applied to it. So we don't have to worry about having multiple references to the same string object. In fact, if you have the same string literal in your code 100 times, Java will create one string object and have all of those portions of your code refer to that same object as a form of optimization. The last piece of our string class here is the toString method, and again this is going to allow us to get a string representation of our employees, and we're going to return a formatted string consisting of 2 string placeholders for the last name and the first name, and then additional string placeholders for the hire date and the birth date. Notice that we have objects of type date that we're outputting here, as strings. So remember, anything that you output as a string, any object you output as a string, gets its toString method called automatically to obtain the string representation of the object. And that's happening here as well. HireDate.toString is being called implicitly to place the string representation of the hire date here, and BirthDate.toString is being called here implicitly to specify the birth date string representation at the end of the format string. And finally, we have our test application that shows you creating an object of our employee class that consists of objects of string and date classes. In this case, we create in main a birth object of type date, July 24th, 1949, and a hire object of type date, March 12th, 1988. And we use those along with two string literals to represent the member objects, if you will, the instance variable initializers for our employee object. We have an employee whose name is Bob Blue with a birth date of July 24th, 1949 and a hire date of March 12th, 1988. Now the two date lines are going to result in output because in the constructor for class date we were showing you when the date objects were being created, and then down here at line 12 we output the employee object, and the println method only knows how to output things as strings, so what it does is it automatically invokes the toString method on this employee to get the employee's string format. Let's go ahead and run this so you can see the output, and you can see here when our two date objects got constructed, they did indeed print lines of text for the birth date and the hire date, and here is the string representation for our employee object for the employee Bob Blue.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.